Okay, I'm going to talk about what I did for my master's dissertation in Southampton University. I was looking at ways that you can kind of interact with artefacts remotely. The idea for this came from the Nautical Archaeological Society, who came to us at the university because they wanted to run their training session, which involves dealing with artefacts and object handling for the public, so non-archaeologically trained people, but they wanted to offer this remotely. So they wanted us to put all of their artefacts into digital format and put it on a web browser. I decided to take that idea and try and work it into something that was a bit more kind of intuitive and would replicate the learning objectives and the object handling session a bit better. So just as a general introduction, this research project will focus upon tabletop learning, so like the big touchscreen tables that you can see here. The one on the right is actually the one that we have at the University of Southampton. They're both Windows U touch screens. One is mounted on the wall and one is mounted on the table, but they're both exactly the same screens. And as you can see, there's other examples here. They are actually a lot more common than you realise. Everyone's like, but no one has this technology. But a lot of schools and a lot of universities now do have these kind of screens available. They don't necessarily have to be mounted into a table, but that's just a way that you can change it to change the orientation, which I'll discuss later. So the research focuses were mainly looking at the application of the multi-touch user interfaces, which I shortened to MTUI, although saying that, that's actually a lot harder to say in a presentation than it is when you're writing it down, to display and view and interact with artefacts. We're specifically looking at this with regards to educational learning objectives and within an adult learning kind of environment. Also addressing the ideas of artefact accessibility. By no means am I saying that this is better than dealing with real artefacts, because if you've got the real artefacts, they are the best thing you can interact with and learn with. But in the situation where you've got artefacts that are still in situ, are dispersed over different museums, like if you've got a collection that you have to look at together to understand, or if artefacts are too fragile to be viewed, I'm suggesting that this is the second best way that you can get people to learn and to interact as a group collaboratively with artefacts through using a digital tabletop. I also researched a lot into the CSCL, which is computer supported collaborative learning and computer supported collaborative working, and this is all within learning sciences and human computer interaction. So I looked at a lot of research into that area, which isn't directly archaeological, but I took what I'd learnt from the learning sciences and from human-computer interaction, and then I applied it to the setup and saw how best I could use it in an archaeological context. So, as I mentioned earlier, the case study is the Nautical Archaeological Society. They already have their own training programme. So this is already a society who is established, and they run training programs for just general people from the ages of, they get from 18 to 60, people who want to learn a bit more about what archaeology is about. Specifically, it focuses on nautical archaeology. And in their introductory session, they have a handling session. This basically aims to get the people to look at how you should question artefacts, how to think critically, and they do treat it a bit like a kind of a mystery, kind of finding out little guessing game of trying to work out from all these little artefacts where they could have possibly come from. And they wanted to make the training more available remotely, so they can put all of their slides and everything online, but they needed to deal with the fact that the artefacts can't be in more than one place at one time. So I took the fact that they do focus on the group work and collaborative learning and the inquiry-based learning quite heavily, so I needed to think about how I could make this available remotely without losing the group work and working together, because it was very much a group task that they would do as one. They wouldn't have like one person look at one artefact, one person look at another. It's very much collaborative. So the aims of the research project were to advance our understanding of how these multi-touch interfaces can have a positive impact upon adult learning, also allow us to bridge the gap between artefacts and the viewer, whether it's because the artefacts are dispersed, whether or not they can be touched because they're too fragile, or whether or not they're still in situ. For example, a lot of artefacts are still at the bottom of the sea and the seabed. And then I wanted to take this and design an interface that could be created for inquiry-based learning. So my objectives to make the interface really specific to the needs were to identify how the multi-touch user interfaces had already been used and what had positively worked, what had negatively didn't work, to also take from the NAS their learning objectives, what they aim to teach people through their introductory session. So I needed their learning objectives, their learning aims, and what they wanted to get out of it. I then had to take both of these and develop it into a successful user interface. Easier said than done. Just a couple of abbreviations, just in case any of you aren't familiar, because I am aware that this is kind of heavily into learning sciences and not technical archaeology. These are referred to a lot in learning science literature, is the idea of collaborative, so computer-supported collaborative learning and computer-supported collaborative working, and that's within the human-computer interaction within education. So, one of the main questions I had is why use a tabletop? Because we have a lot of touchscreen devices within society now. And there's tablets, there's phones. To most people, a tablet is cheaper, it's smaller. They may see that as being a better thing to use. But I wanted to use the digital tabletops because it replicates the original handling session. Originally, people were given a box of artefacts. They'd all sit around the table together, very communal, very kind of, it's natural for us to collaborate around the table. So if you replicate this with screen, it's already becoming more intuitive. You're not thinking of it as a computer screen with like an up, down, left and right. It's more of a table that you interact with, you sit around it. There's also a wealth of literature supporting the benefits of using tabletop computing within education. It's mainly been used within primary and secondary education. So for children's education, there wasn't that much data or research into adult education. So I wanted to take what I'd read within all the positives that they'd come up with in examples for secondary education and apply it to archaeology specifically and base it towards an adult kind of learning environment. Also, due to all the computational advancements, the big touchscreens are a lot more readily available. I mean, not everyone's got them, but with the way that I designed and implemented the interface that I'll talk about later, it runs through the browser, so you can actually view the software on your phone, although it will be tiny, or on an iPad. Okay. So before I could design the interface, I had to take into the considerations of the screen size. You don't want it to be too big, people can't reach over the table to get at objects. Also the orientation. For me, I really wanted it to be horizontal, like a table. This also means though that you get rid of your traditional up, down, left and right. So I had to enable all the artefacts to be moved around the table regardless of where the user was standing. So you have to get rid of the traditional thought of there being an orientation to the screen. There is no left or right, every side is accessible. There's also the discussion of mouse versus touch inputs, and although a lot of research has shown that mouse input is more accurate, when it comes to collaborative learning, the touch input is a lot better for making people aware of each other's movements, awareness of each other and collaboration. It is less accurate for physically interacting with artefacts, but because the group is working together, they quickly learn to work around each other and to learn from each other's movements, whereas if you've got one person at a computer screen with a mouse, they're kind of taking control of the group and everyone else is kind of sitting around and they're not interacting naturally like they would be if they were given a box full of artefacts on a table. Whereas if you've got digital artefacts on a table, you're kind of moving more towards it being how it would be in the original lessons. Also, like, don't just use funny, shiny technology because it's new and you want to use it. You have to really consider why you're using it, take into a lot of consideration how you're going to reach your learning aims and objectives through using the software. So with my research strategy, I did an explorative case study of the NAS introductory session, and I used interviews with the NAS course leaders, questionnaires with the members, or the participants who came along. I wanted to see if they were used to using computers, if they were familiar with touchscreen. I also wanted to see if they found that the object handling session was fun and enjoyable, and see if that was something that they really enjoyed as part of the learning experience, because not the whole day was based around object handling. I also did an ethnographic study where I brought the physical artefacts into the space within the university where the touchscreen was located. So I put the physical artefacts on the touchscreen table and I got a group of people to interact with them. So I could then observe how they worked within that actual digital room with the real artefacts to then work out how best to implement it into a digital version. I also took into consideration of ethics and got approval for taking part in everything. Also, the limitations and potential problems. This was my master's dissertation, so I was limited to time. Because of this, I could only get a small sample of about 30 participants, so there is an issue with if the data set was a big enough representation. I did, however, go to 3 different handling sessions, so to try and get a broad range of participants to answer questions, and there were people from 18 to, I think, the eldest was about 55, so I got quite a good age range as well, and it was all positive replies. Also, you've got to consider the validity and reliability of the data, so I tried to make my questionnaires as non-biased as possible, so there was no systemic bias within them. With the interview results, it reinforced the need to get a greater understanding from the artefacts through asking simple questions which would lead to an interpretation. They also kept it quite fun, light, and they would kind of approach it like a mystery solving adventure. And they really did focus upon the collaborative learning. The group would work together, they would all chip in ideas, they'd be moving artefacts around with each other. If you'd given the box of artefacts to one person, they probably wouldn't have found it as easy to come up with ideas and to come to a kind of conclusion, whereas as the group they all really enjoyed it and worked together, shared ideas, and would kind of like bounce ideas off each other. They would also kind of teach each other that they're going to have different perspectives and that they should all work together. And within the handling session they had a PowerPoint on the wall. It would just kind of like prompt them to think about what, why, where, when. With the questionnaire results, all that right now, that's just the questions, you don't have to pay attention to it all. But you can see from A, B and C, so the first 3 columns, you've got a really strong agree and strongly agree to the questions being asked, like they found the handling session enjoyable, they felt that they'd learned something new, and having the artefacts to handle made it easier for them to interpret. You can see that they strongly disagreed or disagreed with questions D and F, which is that they would have found it just as easy to interpret the site looking at pictures. They strongly disagreed with this. They also strongly disagreed when they were asked if they felt the object handling session was not helpful. So from the actual questionnaire results that I got, there was a strong correlation between the participants enjoying the hands-on approach of the artefact handling, and they felt it really helped them to interpret the site. I did also ask some questions about computer usage and if they owned a smartphone or a touchscreen device, and over 85% of the group answered yes to this. I am aware that there will be a couple of people in the group that weren't going to be familiar with touchscreen devices, but because of the collaborative learning environment, it's easy for someone to show them what to do, and they can pick it up and learn from each other, so they're not going to feel isolated or not know what to do. The ethnographic study results, so this is where I brought in the real artefacts into the digital room and put them on top of the touchscreen, showed that the participants would sit around the table with the big touchscreen on all four sides. They didn't treat it like a traditional computer where you all go from one angle of the screen. And all the objects were studied simultaneously. And this definitely would point towards the fact that we need to make this multi-touch. We need to have everyone interacting at the same time. Luckily, the Windows U touchscreen does have the capability of this, so you can have 32 simultaneous touches at the same time. Also, the discussion would go across the whole table, and the artefacts were moved around fluidly, and any that weren't being used would be discarded in the middle of the table. So I wanted to kind of replicate this digitally. Yeah, and again, they found it exciting and found it a lot easier to share knowledge working together rather than just viewing artefacts on a screen. So the design process, you had to ignore my very crude sketch. What I envisaged doing was having horizontal orientation with artefacts scattered about, so you've got users sat all the way around the table, and you're able to rotate, to scale, to move objects around. And on the right hand side there would be a widget with questions to prompt them, so make them think critically, just to help them along a bit. That would supplement the PowerPoint that would go along with handling session in the original version. Also, there is the fact that digital artefacts are going to lose some information from the original ones, like you can't heft or feel the weight of a digital artefact. So I wanted to add in some extra hotspots that you could click on the object, it would come up with its weight, or some images with finer details, or even RTI images. Also, the main thing I wanted to make sure this would work through the web rather than requiring people to buy expensive software or have to have software and devices enabled specifically. This will run through any device that's got a web browser. You just download the Unity plugin within the browser and it should work fine. When I was implementing it, I had laser scan data and RTI data given to me, thankfully by James, and I then processed that in MeshLab and 3ds Max, and I then, due to time, because it was my dissertation, I got some help from Michael Klein at 7 Reasons. He helped me to program it into Unity and get it running in the web player. We also had to add in a touch user interface framework because unfortunately Unity isn't natively touch, so we had to get a program to speak between Windows and Unity. We did get it working to a point, but like most things, it's not going to be simple. I also I chose to use Unity because it's free and it's open source, and there is a massive community of support out there for helping with programming. Okay, so this is what I actually ended up building. As you can see, it's quite different from what originally was sketched. We ended up having to put each artifact into its own local square, where you would then click on it on the buttons at the top, where you choose I'm going to rotate it, I'm going to scale it, or I'm going to move it. So by clicking on the circular button of what action you wanted to carry out, you could then do this. Unfortunately, we couldn't get it working with multi-touch, where all the artefacts were in one global area, because then it would interfere with all of them, so we had to put them into their own kind of local boxes. And there's a close-up here, you can see the button on the left is when you want to move it around the table, or to rotate, and then the scaling. So within that, you can move it around, you can interact with it. So when I got a second group in to try it out on the big table, I got them to give me positive, negative feedback, and the negative feedback that I received just reinforces the design ideas that I had that unfortunately didn't work straight away. because of the time constraints and the programming problems that we faced. So it's kind of like a work in progress. They found it quite frustrating because only one person could touch objects at once. Unfortunately, the multi-touch didn't quite work for some reason. We're still working on it. But we did get touch working in the first place. And they wanted more information on the screen, like widgets, which is what I planned to do. But again, unfortunately, due to the time and programming, we didn't have time to finish it. But you can see on the positive feedback, they enjoyed playing with digital artefacts. They found like the mystery game to be quite entertaining. They liked the fact that you could touch the artifacts rather than using a mouse. They felt that the screen was good size. They could actually reach from one side to the other. And they felt that the objects were intuitive and easy to manipulate. It was very simple gestural movements. So to conclude, the user interface that we designed allowed participants to access artefacts remotely through touch. Also, it allowed for accurate digital representations because the data or the artefacts were laser scanned, so we haven't modelled in any extra bits, it's all laser scanned data. It allows them to work collaboratively and intuitively rather than having a group huddled around one PC screen with one person taking control of the group. They all could work together, nobody was like singled out, they'd all discuss things and work together like around the table in the original handling sessions. It also allows people to gain access to artefact collections that wouldn't otherwise be accessible, I've discussed earlier. So I was proposing that this would be the best way for the NAS to remotely allow their introductory session, like object handling session, to be sent out over the web. But with everything, there was a lot of further work to do. So we're continuing to develop the user interface. So I'm working on getting the widgets working, getting extra information in there, getting the multi-touch working. I'm going to do more studies and feedback, and also look into the use of haptics, which will allow people to actually feel and touch the objects, because that is that's massively missing with any touchscreen interface. You don't get to heft objects, you can't feel the texture. Also, there are advancements in software and hardware already, because when I was doing this, at the same time, the Microsoft Surface came out, which had loads better technology on it and possibilities, whilst I was stuck using this thing. And so I'm pretty sure if I tried to build it on one of the newer Surfaces now, it would work a lot smoother. Yeah, so that's about it. And a massive thank you to James, who's here, because he did all the laser scanning for me. And to Michael Klein, who works over at 7 Reasons. He managed to get it all working in Unity for me, because I couldn't learn everything in the space of 3 months. So I was trying to focus on all the theoretical side of things. If you've got any questions, give me an email, because I've just condensed 20,000 words into 20 slides. So you can have a copy of my dissertation if you want, or email me questions for more details and stuff. That's it.